Had a question, this one from the homework, 2957. And this one here is an example where the book is kind of being a jerk to you. So they're writing this circuit in a way where it's not really clear what's happening. But my argument is that this circuit is the exact same thing as the one I'm drawing right here. Okay, and this is where I was talking in class how it's really tricky sometimes how to see how the circuit is set up. And so this is an example. We're going to do tons and tons of examples of this in the next couple of weeks as circuits. All right, but if you look here, okay, this capacitor, and this capacitor all sort of have this little equal axis. They can go straight. They're on one end. They're connected directly to the top end of the battery. Okay, and so that's what this guy, and this guy would be. And then all three of those capacitors, then they go down to their other capacitor, that bottom C. So that guy would be this one right here. This one kind of swirls around over to here, and this one scrolls around to this guy here. So that would be those two C's right there. And then those three capacitors are all then equally hooked up to the bottom end of the battery. All right. And so this first picture is very scary. This picture still is scary, but it's a lot less scary. And also, once you draw it this way, part B, so if you look here, this would be where I'll be calling that point A, and this would be where they're calling that point B. Okay? Since these capacitors are equal, then the voltage difference between V and A has to be 0. Right? Because the potential difference across any of these two capacitors has to be this 12 volts of the battery, and since they're identical capacitors, they're going to basically be sharing the 6 volts equally, and so the A and B is going to be the exact same potential. Okay, and so you can get that just from right there. Now, to find the equivalent capacitance, this is you go through and you do the procedures like we were doing the other day in class. So here we got two identical capacitors. What's nice is they're all identical, so you don't have to worry too much about numbers. And so here you would say, okay, I got three sets of capacitors, CC and CC, that are all in series. So these two guys here are in series, these two guys are in series, and these two guys are in series. So the series equation, again, is the uglier one. So 1 over C equivalent equals 1 over C plus 1 over C. Now, this would give us 1 over C equivalent. If I add these together, it's just 2 over C. And so if I flip this over, I get C divided by 2. All right? So when there are two identical capacitors are in series, all right, the equivalent capacitance will be C divided by 2. So I can replace that circuit with three equivalent capacitors of a half divided by C each. And so this would be my next circuit down the line. And now these are in parallel. When it's parallel, it's the easy case of just adding them up. So it's C over 2 plus C over 2 plus C over 2. And if you add 3 halves up, you get 3 halves C. So that's the equivalent capacitance. So we have the simplest circuit in the world, one battery and one capacitor. The equivalent capacitance of all that stuff would be 3 halves C. So again, this is one where it's really tricky because of the way they drew the pictures. You got to be super careful of taking that picture and trying to draw it in a nicer way.